This is basic lesson 3, probability, stats, and data analysis. I'm going to start out by talking about what mean is. And this symbol here means summation. It means sum all of your numbers. And then n means dividing by how many numbers you have. So let me just show you an example, and you're familiar with the mean, I'm sure of it. Jimmy's final grade is the average of his test scores. Average in this context means mean. That's 5 tests. If he received scores of 78, 83, 82, 88, and 94, what is his final grade? So to find the average, or mean, we're going to sum all the numbers. 78 plus 83 plus 82 plus 88 plus 94. And divide it by how many numbers we have. We have 5 numbers. If you sum those top numbers using a calculator, you get 425. If you divide that by 5, you're going to get that his average score was an 85%. Number 2, Riley loves iced sweet tea. Not knowing how much sugar to use, she researches recipes online. She finds that 4 recipes tell her to use 1/4 of a cup, 2/3 a cup, 3/4 of a cup, or 1/3 of a cup. So 4 different recipes, each one telling her a different amount of sugar to use. She decides to average these sugar amounts together. How much sugar should she use? Well, to find the mean, I'm going to add up all the numbers. And divide by how many numbers that we have. We have 4 of those numbers. So use your calculator to add up these top numbers. 1/4, 2/3, 3/4, and 1/3. You will find that that sums to 2. And then 2 divided by 4 is going to be 1/2, or 0.50 cups of sugar. So she should be using 1/2 a cup of sugar if she wants to do the average amount. Bailey runs cross country, and her last 5 meets she ran in 15.75 minutes, 15.5 minutes, 16.25 minutes, 14.75 minutes, and 15 minutes. What was her average race time for her last 5 races? Once again, to find the mean, you're going to sum up all the numbers. And you can just use a calculator to do this. Divide by the total number of numbers. We have 5 of those numbers. It's going to be 77.25 divided by 5. Her average race time is going to be 15.45 minutes. This last problem is a little bit different. 6 numbers sum 18 and 3/4. What is the average value for the numbers? Well, we're trying to find the mean, the average. The numbers have already been summed for us. 18 and 3/4. And we're told there are 6 numbers. If you put that into your calculator, you're going to get 3.125, which is also equivalent to 3 1/8. Now we're going to talk about probability. The probability of an event happening is the number of favorable outcomes divided by the total outcomes. Just a quick example. Let's say that you were to toss a coin. What is the probability that you would get a head? What are the number of favorable outcomes? How many heads are there on a coin? There's 1. How many total outcomes are there? Well, there are 2 sides to a coin, a head and a tail. So the probability of getting a head is 1/2. Let's just do another real quick. Probability of rolling a die has 6 sides, and that rolls a 3. Well, how many 3s are on a die? There's 1. It's the number of favorable outcomes. How many total outcomes are there on a die? There are 6, because there's 6 sides. So the probability of getting a 3 is 1 out of 6. Example, during a school assembly at Port of 120 students, there are 40 fifth graders. If one student is chosen at random to make an example of, which probably means a beating of epic proportions, what is the probability that a fifth grader would be chosen? So, probability that we are going to get a fifth grader is equal to, the numerator is the number of favorable outcomes. How many different fifth graders do we have to choose from? We have 40. The denominator is the total number of students that could be chosen. There are 120 students in the class. This reduces, you can divide both 40 and 120 by 10. You can divide both 4 and 12 by 4. This reduces to 1/3. So that means the probability of them picking a fifth grader at random is 1/3, which is answer E. Now this question has all the same information, but the question's different. It says, what is the probability that a fifth grader would not be chosen? So if you just think about this logically, if there's a 1 in 3 chance that a fifth grader would be chosen, then that means that there is a 2 in 3 chance that they would not be chosen. There's a couple different ways that you can reason that out. One, the probability that the biggest probability that you could have in any situation is a 1. That represents all the different possible outcomes. So anytime that you want to figure out a probability, so once again, let's say our probability that a fifth grader is chosen, we know that is 1/3 from the previous problem. So the probability of it not being a fifth grader, you could say we have all the chances, which is 1 out of 1, minus the 1/3 that could be fifth graders. That gives you 2/3. Another way to look at it, if that doesn't float your boat, probability of not being a fifth grader, how many not fifth graders are there? Well, there's 120 students total. 40 of those are in fifth grade. That means 80 are not in fifth grade. And 80 over 120 reduces to 2/3. So no matter how you look at it, the answer is going to be 2/3. So interpreting data. Tables below show the number, type, and cost of soda purchased during 1 week at 2 different gas stations. So we can see here at Tony's, there were 60 cans of Coke purchased and 20 bottles of Coke. Pepsi, there were 69 cans and 21 bottles. Mountain Dew, there were 43 cans and 17 bottles. At the Black Lung, there were 44 cans of Coke, 18 bottles, etc. Then it tells us down here what these things cost. Coke cost 45 cents for 1 can and 69 cents per bottle. Pepsi was the same cost per can but 79 cents per bottle, etc. The question is, what is the total cost of all Pepsi sodas bought at these 2 gas stations during the week? So let's check this out. So looking at Pepsi. So we're looking at this information, and we are looking also at this information. So there were 69 cans of Pepsi purchased. Hold on 1 second, technical problem. There were 69 cans, and those cans cost 45 cents. Plus, there was 59 cans from the Black Lung sold, and those were also 45 cents. And then looking at the bottles and the bottle prices, there were 21 cans, 21 bottles I should say, at 79 cents a piece, and there were 25 bottles at 79 cents a piece. So what you're going to be doing is multiplying these numbers together and then adding those sums together. Or you can just type this whole thing in your calculator at once, which is probably the best choice because it's going to save you time. You're going to get $93.94. What is the approximate average number of pass completions per quarter in the championship game made by Team A? So looking at this table, pass completions, here's the vertical column. Along the bottom we have the different quarters. Team A is in black, Team B is in white. It's asking for Team A, so I'm just going to trace over that a little bit darker so we can see that better. It's pass completions per quarter. What is the average completions per quarter? Well, in quarter one, there were 12 completions. Average is mean once again. Quarter two, it's halfway between the 6 and the 4. It looks like there might be 5 completions. Quarter three, looks like it's halfway between the 6 and the 8, so maybe 7 completions. And then quarter four, it looks like there are 10 completions. There are 4 quarters total. So this works out to be 34 divided by 4, which is 8.5 completions, which is answer B. If you could be swell enough to do exercise set 3, it would be greatly appreciated.